Hello, my name is Can Davutoğlu. I'm the Chief Marketing Officer of QiTASC, and I would like to describe how we are testing voice bots, any kind of voice bots, in real conditions end-to-end. So, as you know, AI-driven voice bots are becoming more and more interesting and more used. So let's assume we have here a telephony environment which is connected with a telco switch where you have incoming calls. And then you have here your AI chat / voice bot. You have here your databases and your applications. You have your speech to text and text to speech application. And when a call comes in, there is a reason for that. The AI chatbot tries to answer it. It writes some data into the database sometimes. It retrieves data out of the database to answer the questions. It writes some logs in order to have a proof what it did. And this is the environment which we want to test. So this is system under test. We from QiTASC, we have created a fully automated test environment for telephony applications. So regardless what you have, if you use mobile devices with 2G, 3G, 4G or 5G, or if you have some special handsets with 450 megahertz, or if you have a desktop phone with some touchpad with buttons and so on for IP telephony, or if you even have an old analog phone, you could have a fax machine. In Europe it's still used. Even you have these kind of things where you have some communication needs to a call center. You have these different kind of devices, and in the middle you have, of course, the telephony network. So what we did is that we have created Intact. Intact is our solution, and Intact is capable to control all these devices. So we are connecting ourselves to these devices via USB. In some cases, we are connecting ourselves with HTTP. We do emulation of analog lines. We can control fax machines. And even if you have something else which is working with data, we are also capable to control an environment where you have a monitor, an application, and control that. And this is done fully remotely, so the tester can sit somewhere. You can have it in a lab, or you can have it in a real environment. And now we are capable to trigger telephonic calls to this environment. And what we also did, so we are using Cucumber with the Gherkin syntax. We have developed also some specific step definitions. And these step definitions are also dealing with an AI infrastructure. So we have our AI infrastructure. This can be set up at Google or Azure. And here we have our own bot. So there is a QiTASC bot where we can tell this bot to act in a certain way. We have also our text-to-speech and speech-to-text engine provided also out of this environment. And with plain words, we can describe the task and tell, please call. And the bot starts that. And this functionality is combined with the controlling functionality of all these devices. So we can initiate a call from here to here. This part picks up and says, hello, welcome. Can I serve you somehow? and the bot starts, yeah, I would like to have a meeting arrangement for a certain time. Can we book that? And they talk to each other. While they are doing, of course, on this side, we are collecting these logs. On our side, we are collecting our logs. So all the transcripts, everything what has been done by these two bots is available. We are capable to measure the MOS quality of these activities. We are capable to verify if there is silence in the communication, how much second the silence is. We can identify what this part is saying, how often they make mistakes, if there are some fillers used on this side. And we have created a score where we can measure the quality of such a communication. For instance, 30% of the score is fulfillment. So this means if the bot who is calling is finally getting his arrangement, his meeting dates, then it's fine. If the quality is bad, then the score will be slightly less. If there are no fillers, the score will be slightly less. So we have really a scientific approach to create a quality score for such a combination. Thanks a lot.